Hello everyone, welcome to today's masterclass. I'm Josefina Sautri, Product Marketing Manager here at Ziggurat. Thank you all for joining us today. So just a quick overview for those of you who may not know us. Ziggurat is an online institution. So we provide master's and postgraduate programs in architecture, engineering, and tech management. We have over 20 years of experience in e-learning. And we have a very, very wide community of students and professors. There you can see a photograph from our last student week. We have people, more than 20,000 people from 120 different countries. So it's a really exciting community that we create. So this masterclass is related to one of our programs, the Masters in Global BIM Management in Civil Engineering and GIS. In fact, Mostafa is a professor there. So it's a one-year program. There you can see the academic structure. It's also a very hands-on program at the end of the program, the students present a master's thesis. And so you can scan the QR code and then see more details there. So Mostafa ElAshmawy, he's Managing Director of Proline Engineering Services. And without further ado, I'll hand it over to you. If you have any questions or comments, please leave them in the chat below. I see Krishna, you have your hands up. I think it's better for us to leave the comments and questions in the chat, and then Mostafa will address them in the end, okay? So I'll stop sharing my screen. I hand it over to you, Mostafa. Thank you.
Thanks a lot. Give me one moment to share my screen. All right, so I'm sharing my screen now.
Yeah.
Can you confirm that you can see?
Yes, we can see that.
Good. All right. So thank you for the introduction and welcome everyone to this masterclass on integrating BIM into railway projects. I'm happy to be with you here, and it's my first online webinar from Australia. I've moved to here recently, and yeah, you would realize that there is a huge time difference, but yeah, happy to be here with you. And over the next 45 minutes to 1 hour, I'll go through how can BIM support railway projects through visualization, improved coordination, and also we will go through the potential for BIM to support operation and maintenance post handover. And in this session, most of the information shared here is based on 2 modules that I teach in the master at Ziggurat Institute, and both modules, one is related to the design and one is related to the operation and maintenance. I'm Mostafa ElAshmawy. I'm a senior BIM and digital delivery consultant. I have worked through my career in digital engineering and BIM. I've always been supporting open standards and the use of digital engineering solutions and implementing digital construction, digital twin as much as we can. And I'm a heavy fan for all new technologies, and I always try to promote them. I'm also certified from some organizations. I'm also holding a Master of Global BIM Management and a professor at Ziggurat. However, as I mentioned, I'm certified from several organizations, and I've worked with some of the organizations in the Middle East. Some of them are related to the construction industry, where I played. I worked for long part of my career with design and build contractors, and also worked with consultants and with clients. However, in this presentation, I'm just representing myself based on my knowledge and experience. So if there is any mistakes, please just consider it sincere or just from me, not representing any organizations. Going through our introduction in today's session, this session is designed to give you an understanding of the applications of BIM in the railway industry and how it can differ from other projects. I've worked in railway for around 6 years of my career in Riyadh Metro project, which was one of the largest railway projects in the Middle East, and I think in the world. And at that time, I started working there from 2014 to around 2020, and BIM itself was developing through this time. So the way we used BIM at the start of the project was different from the way we used it at the end of the project, and there was always potential for better implementation of BIM. And in today's session, we will explore how this can lead to better decision making and stakeholder engagement, coordination among multidisciplinary team in some aspects where BIM shines, and how this can help also in avoiding conflicts and streamlining processes. We will also go into some details about the way we teach the modules related to railway in Ziggurat Master, and how we are covering both the theoretical and informational part, and also the software, and we are focusing on a specific workflow focused on Autodesk InfraWorks and Civil 3D, where we explore how the tools of both software can support BIM for railway. So as a start, I always like to start speaking about BIM by going into one of my favorite definitions for BIM, which is crafted in ISO 19650. We all think that we understand what BIM is, but from my point of view, the perfect definition for BIM was crafted there in these standards, where it was said to be the use of shared digital representation of a built asset to facilitate design, construction, and operation processes to form a reliable basis for decisions. So from my point of view, BIM is a facilitator for all the other functions of the process. It facilitates design, it facilitates construction, and facilitates operation. And when we speak about railway projects, the design and construction and operation is much complex, and it's rare that you'll find a railway project that's small. Most or almost all railway projects are on city scale or on a country scale. So usually these kind of projects have huge complexities that require the power of BIM in facilitating its aspects. BIM in general offers multitude of benefits that significantly enhance the efficiency and effectiveness of construction project. And one of the most notable advantages is improved visualization with the 3D models, where stakeholders can see the project in a realistic digital environment, but not only the 3D geometry, but also enhanced with information where the any stakeholder, whether the delivery teams or the client teams or even the stakeholders that might be impacted by such projects, can have access to 3D representation together with information to understand the impact of such projects on their assets. By integrating the designs of various disciplines in BIM, we can detect clashes and conflicts as early as possible on site. And again, when we speak about clash detection for such kind of projects, everything is multiplied. The size of work that we have in railway projects is not comparable with a building project or others. So, because a railway project usually have various types of buildings, stations, parkings, links to existing airports, links to bus stations. It have a depot. It have various types of buildings in addition to the railway itself. So all of these items require the power of BIM in improving the collaboration and coordination through the design, and also support through the planning phases of the railway project. And in addition to this, futuristic use in the operation and maintenance of these projects. And the application of BIM in railway has witnessed a revolution recently with BIM used for design and build, and for some cases in operation. And one of the primary benefits of BIM in railway is the ability to create detailed and accurate 3D models of complex railway systems. These models provide comprehensive visual representation of the entire project, from tracks and stations to signaling, communication systems. These enhanced visualizations helps the engineers and stakeholders to understand the project better, identify potential issues early, and make informed decisions. BIM's ability to facilitate the coordinations, as I mentioned, is important for railway projects. And we have seen many examples where BIM also supported the construction planning and the logistic planning for railways. We have heavy equipments, we have roads, permanent roads that need to be, for example, closed to facilitate the construction of railways. And as I always say to my students, that it's rare that you will find a new railway developed without an impact to existing transportation systems. So usually using BIM can facilitate logistic coordination and site coordination with other transportation systems that's ongoing and usable by the community on the time of construction. That might include roads and might include other rails, and also any other ways of transportation. So BIM provides this comprehensive digital record also of all the railway asset, including their specifications, maintenance history, operational status. So we can load all the required parameters into our BIM models, or to link it to the BIM model, either directly in the BIM model, or link it to it, or add it to in a common data environment in a way accessible for the end users of this project, or end operators for this project. And we can't speak about BIM without speaking about standards and how essential essential they are, because it's essential for the effective implementation of BIM across construction projects. And it's not only about just implementing ISO 19650, but it's more about understanding that ISO 19650 is an international standard. So for sure, we must also align with any national standards that's available. And in case that's not available, a project should develop its own standards, methods, procedures aligned with the best practices and aligned with ISO 19650 to ensure that at least there is this standardization across the project itself. As a railway project, there should be organizational information requirements for the entity owning this project, and also there should be asset information requirements and project information requirements. And from my perspective, asset information requirements is very essential when we speak about this kind of projects that will serve the public and will last last for a long time. It have a longer life cycle. So for these kind of projects, asset information requirements should be defined as early as possible and should be implemented properly from the earliest stages in the project. Also, these kind of projects involve the use of various types of modeling software and various types of platforms to support the development of this project. Usually, the stakeholders involved in railway projects are international entities. Usually in these projects, you will find local contractors, local consultants, and also international teams. And usually every team would have specific software to work with, and we can't ensure that these teams are using their tools without implementing proper interoperability methodologies, like ensuring that IFC is used as an end format for deliverables. So in such projects, it's not recommended to rely on the native files, because it's important to have this kind of open format that can absorb all kind of platforms and all kind of software, not only for the design and construction, but for linking with other future platforms for operation and maintenance. BIM processes are essential. So for sure, standards are important, but also the specific processes related to the projects as important. And the most process that should be properly defined is a common data environment. In projects with large size, it's very hard to stick to a single common data environment and make it and use it as a centralized common data environment. You need to be flexible to shift from using a single common data environment into an ecosystem of common data environments. So you need to be able to absorb the various types of common data environments based on the use case for each common data environment, and ensure that you have proper process for these platforms to talk to each other. So you might have an electronic data management system for formal communications that's trusted by the owner, but also you might need to have another common data environment that's well known for the collaboration, or have better methods of navigating the models or enabling reviewing systems. So you need to have this flexibility, and this flexibility can't be achieved without a proper process that ensure that all the aspects of common data environment is implemented, including naming conventions, proper revisioning systems, suitability codes, and all others. Also, the BIM execution plan or digital engineering execution plan, these kind of documentations need to not only be just documents to fill the deliverables, but to be actual documents that represent how the project and the BIM deliverables will actually be developed and fill the BIM uses and the BIM goals for the project. In the upcoming part, we'll speak about how BIM mainly is supporting the optimization of design, and one of the most important uses of BIM for these projects is the visualization. Usually for such projects, before or at the early stages of implementing BIM, we used to have the 3D models developed in BIM isolated from the 3D models developed for visualization. So we saw many organizations that develop BIM for production of drawings, but on the other hand, they go and use, for example, 3ds Max or any other software to develop a realistic model that can be used in the visualization and giving a better understanding of the design. But with the advancement of BIM, it became feasible to use the BIM models, and just with some fine tuning and final touches, it can be then embedded directly into a visualization software. So currently there are many software that can provide this high resolution imagery using BIM models. For example, InfraWorks, for example, Lumion, and many others that can make good use of BIM models for visualization. And why using BIM for visualization is important, why we can't just stick to this older methods or traditional methods. It's because the main purpose of visualization is to get better understanding of design and design options. And when you have a complex project like railway, you need to have accurate representation of the design. And usually when you develop a visualization model without using BIM models, these models are not that accurate and misses lots of details. But if you have proper implementation for BIM, these BIM models can be used to engage the proper stakeholders at the correct timing to get their inputs and get informed decisions at the correct timing. Also, the proper visualization using BIM models helps in identifying potential issues as early as possible. So you might be putting more efforts in developing an accurate BIM model at early stages, but in return, you are detecting the problems in early stages. So in general, the using BIM for visualization is shifting from just being an extra or an just a good way of just making a fancy model that everyone can see and be impressed, but to actually understand the design and take informed decisions. Another important part is design coordination, and it's a fundamental benefit for using BIM in railway, and involving all the engineering disciplines in the same space in a proper common data environment, enabling them to collaborate. And in today's world, you have the designers scattered all around the world, and you need these teams to work together in an efficient way, and you can't do this without BIM. BIM and a proper common data environment that hosts the BIM model with cloud-based solutions. This is where such various engineering teams can work together, including the structural, electrical, mechanical teams, and also the specialized teams that can have their specific BIM models for any miscellaneous equipments or wagons, for example, or any other elements of the railway modeled in BIM also. BIM addresses this challenge of coordination by integrating these designs of all disciplines into a single federated place. And if we if you previously had a look on ISO 19650 standards, when it comes to coordination, and federation of models, the example that's used in these standards is a railway project where a volume strategy should be developed at early stage to ensure spaces are reserved for specific systems inside the cross section of railway to enhance the collaboration and enhance the clash avoidance. Effective design coordination also using BIM helps in reducing the risk of errors and rework during construction. When all disciplines work from a coordinated and accurate 3D model, the likelihood of encountering issues on site is significantly reduced. And this leads to smoother construction processes and fewer delays and lower cost. Also, integrating all these disciplines in one place serves as powerful communication tool. So a workshop with BIM model in place where everyone can see the models saves lots of time of various communications or discussions using drawings. So having BIM tools for these complex designs is essential. So in summary, design coordination using BIM is becoming essential, and from my perspective, if we are running such projects without using BIM, we are wasting a huge opportunity for saving. Yeah, and as we speak about coordination, for sure, we must mention clash detection. And as I mentioned, clash avoidance is an important concept when we are designing a railway project, and it's one of the aspects that's usually developed at early stages. So imagine you are developing a railway in a tunnel, for example. Every service have its allocated location from early stage, and I would say that clash detection is for sure, it's not something very specific to railway, but as I mentioned, the size of the project make such saving using clash detection from early stages is multiplied when you talk on railway projects. Parametric design in railway is also one of the advanced features that BIM offer, and it offers a significant advantage for railway projects because it's not only about going and modeling and drafting every single detail, but there are values that just can be added to develop the model quickly and saving huge amount of time in that development. For example, in railway projects, the tracks, the alignment of tracks can be developed based on specific rules or specific values that we can input numerically without the need of going into the details, and also the cross sections itself. Sub-assemblies in Civil 3D, for example, can help in developing the railway cross section and maintaining its relation with the existing ground automatically without the need to study every single place for cut and fill. This dynamic and flexible approach to design has several benefits. So it enhances the accuracy and reduce the risk of manual errors. It also enable the quick iterations and optimization. And I recall an example that we used in the railway where specific automation for railway was used to develop in Civil 3D, but also with the support of Dynamo, where some information were not available at the time of the development of the design at the early stages. So some data were assumed, and the way they developed this design, they ensured that it can be edited automatically once they input the new values, and this saved them huge time, and also avoided them from waiting till they have all the information. So they were able to start with some dummy data, and then once they have the proper information, they were able to complete their work. Enhancing the design accuracy is an important part that BIM adds to the process, and it doesn't require a lot to mention that having the elements developed in 3D and having the views reflecting any change at the same time enables designers to have accurate and more efficient way of developing the finer details. One of the important aspects that BIM add to the process also is improving the stakeholder engagement. So as I mentioned, using BIM, it's much easier if, for example, you used a platform like Autodesk Construction Cloud or Revisto or whatever solution. It's much easier to ensure that everyone have access, and even some platforms currently don't require advanced BIM use, so you can enable the access to the in-progress design or the approved versions of design to any kind of stakeholders, the usual stakeholders in the construction projects, and also the community itself. You can enable the community to see how such railway project will impact their current homes, their current commuting, and all aspects of their life. In addition to its role in the design, BIM is adding a great value when it comes to construction planning and simulation. And this specific example, I think I will not go and open the link at the moment to avoid any technical issue, but this one of the examples that shows using 4D for railway projects, and using 4D in such a project is not only about having a simulation of the project from start to end, but it can help in resolving specific issues in specific locations where you can not only involve the railway components, but also the external and existing roadways, existing temporary roads, any temporary elements that's used in construction, any equipments, to understand the impact of the steps of construction on the surrounding environment. BIM also enhances quality control and documentation in these projects, and usually quality checks was usually done based on the drawings and the just checklists, but having these models that shows the teams and site teams the end product, so they have something to actually compare with, and it saves a lot of time. This digital model becomes a source of truth that can be accessed by quality teams to ensure that the proper physical asset is developed similar to the digital asset, and also having the BIM model and the concept of common data environment make the control of the documentation much easier. So specific drawings can be linked to specific models, and specific models can be linked to specific packages. So the way of managing documents have improved a lot with BIM, and the role of the information manager that purely can be considered as a BIM role is now very intersecting with the document controlling roles. So document controlling and BIM are about to be considered a very close function. So BIM is enhancing the document control, and the document control currently can't ignore the BIM processes and the common data environment processes. And another point that's essential and BIM add to the construction is the real-time data updates, and it's a significant advantage in railway projects, because when working with these huge projects, it's hard for everyone in the project to memorize which areas are built, which parts of the project is built, and even if it's reported daily basis or weekly basis, whatever the frequency of reporting and whatever the accuracy of reporting, it's hard to comprehend all of these updates without a proper BIM model that can reflect these updates whenever it happens. And when it comes to post handover, BIM has huge potential. And to be frank, not BIM alone, BIM together with GIS and all the digital engineering is becoming an important part for the post handover. And from our perspective as BIM experts, the main concept that supports this is the concept of the asset information model. And asset information models in railway is a critical component, because the life cycle of such a project goes for tens of years. And Riyadh Metro project, for example, was designed for at least 100 years, and most of these projects are designed for much more. And that's why the asset information model, from my perspective, is a real deliverable of BIM. Yes, we use BIM for the construction and to ensure that we deliver the proper project information model, but the deliverable that will be used or have the potential to be used much more is the asset information model. It should capture the as-built status and also any additional parameters that can help the asset operators or the facility managers to operate such complex project. And it's becoming seen in many projects where they are trying to make use of the BIM models, whether to link it with IoT or any kind of management devices or sensors, this kind of devices, to ensure that whatever data captured is seen in a 3D environment that can then enhance decision making for maintenance, for the management, and to report, for example, the condition of tracks, the bridges, signaling system. So when it comes to this aspect, so BIM is becoming the core for the concept of having a digital twin that links the physical asset with the digital asset. And also another aspect where BIM is helping is maintenance planning for railway. And maintenance planning is a critical aspect in managing railway. And on the long term, the performance and reliability of railway assets depends on the regular and effective maintenance activities. And BIM can play a critical role in supporting such planning by providing accurate and up-to-date information about the asset, including the condition and maintenance history and the operational status. And one of the primary benefits also of using BIM for maintenance planning is the ability to access the detailed and accurate information about the railway asset. So this digital model captured the data related to this asset together with design specifications, O&M manuals. All this kind of information are already captured there. So this can facilitate the planning of this maintenance. In general, BIM also plays an important part for the sustainability and efficiency for modern railway project, where as the world moves towards more environmentally responsible construction practices, having BIM in this process help in achieving such goals, because it provides better control on the construction projects, and in return we have more sustainable and efficient design. And one of the primary benefits of BIM is its support to the environmental impact on the project. And there are many projects currently that's using BIM to calculate carbon emissions and to achieve zero emissions. So it's becoming more and more used recently and seen in many projects where BIM acts as a cornerstone for sustainability and efficiency in projects. So in next section, I'll speak about the tools and the workflow that we usually focus on in the master. However, for sure, there are other alternatives, and the design and planning of railway systems usually undergo changes over the years. And recently, the advancement in the tools used for design has supported the development of the design. And when we speak about BIM tools, and for sure Autodesk software are one of the most complete set of software that can be used for the design of railway. However, there are other great solutions also, like Bentley's OpenRail, and also Trimble have their solution, and there are many other solutions that's available. And we always recommend our students to keep themselves aware of the best practices and the best software, and it's our responsibility as BIM experts to always know that the strengths of our tools and use whatever tool that can fits in our process and do the best in our process. The workflow that we cover though is mostly based on Autodesk products, which is one of the also most successful workflows in this field, where for example, Autodesk InfraWorks can be used in the conceptual stage and for the visualization purposes. And from my perspective, Autodesk InfraWorks is one of the most underestimated tools, because it has this capability in linking the BIM world and GIS worlds in a very interactive platform. And Civil 3D for sure for detailed design, Autodesk Navisworks for coordination, Revit for the buildings, and Autodesk Construction Cloud for collaboration. Yes, in today's world also, you might be using for example, Autodesk InfraWorks, but 12D, for example, for the railways, and for example, using Revisto for coordination. So it's fine to use whatever sets, as long as it's defined and as long as you define the process of how these software can work together. Also in the master, we give an overview and a brief and some details on the most important tools in Autodesk InfraWorks related to the development of railways. And InfraWorks is a robust BIM tool designed to support the planning and visualization mainly, but still it have the potential to support also the decision making, because it provides highly detailed models at early stages with less efforts. So using InfraWorks, we can have a complete overview of the design and have all the existing conditions inside the InfraWorks platform, together with the developing the railway projects with the InfraWorks tools to enable this design options, comparisons, and to support the decision making. Then we go also through Civil 3D, covering its railway tools to understand the link between Autodesk InfraWorks and Autodesk Civil 3D, and where this can import to that, and where we can get, for example, a proposed alignment based on a study in InfraWorks into Civil 3D, and then complete the design there, or starting the design from scratch in Civil 3D. And the good thing about both solutions is that it have a proper understanding to the GIS context and the geospatial context, where everything is geolocated based on proper coordinate system. So we go through such details to ensure that our design is seated in the correct location, and this is non-negotiable in railway projects. In this video, this is a quick brief on how the tools of Autodesk InfraWorks are used, where we in InfraWorks, for example, they have a tool for railway, but also they have an important tool related to roads called component road, and it's one of the most advanced tools in InfraWorks, where you can have your railway designed and seen compared to the context of the city, and where you can easily, for example, this is part of Riyadh city, where we have we are developing a railway that will go through a specific location, and we then are able to see the impact of this railway on the existing roads, and where we can add for example, bridge, and where we can add a tunnel for going through the existing environment. So using InfraWorks, it's very easy to control the profile and provide an acceptable, detailed design at the very early stages, so that we can take better decisions. And an important part also of using Autodesk InfraWorks is its ability to export into both Civil 3D and Revit. So using Autodesk InfraWorks, we are able to export the railway path, for example, the alignment and the component of the railway into Civil 3D, and we are able to export the structural elements like the tunnel or the bridge into Revit, and work on them to detail them further in Revit. So I'm just being aware of time, and I want to allow some time for questions. So I will not play this video to the end, but yeah, I think that was my last part in this session, and yeah, I will now allow
Great, Mostafa. Thank you very much.
Yeah.
So Mostafa is joining us from Australia. So I appreciate the time. The time difference is huge. So just I'm going to address a couple of questions that are more related to Ziggurat, and then I'll let you address the rest, okay?
Sure.
So Yasser and Mohamed are asking if we can share the slides with them. Would you be okay with that, Mostafa?
Yeah. Totally
okay, so
fine.
we'll send them via mail, okay? So everybody that's watching this and who's joined the masterclass will receive the recording, but we'll send the slides as well, okay?
Yeah.
And then we have, Yasser also asks the cost of the masters. So that's a question that the admissions department will be able to answer better than myself. So I've left the link of the program. So just fill in the form and they will contact you with precise details of the costs. And then Krishna, I don't know, Krishna, if you want to talk. So I'll open the mic if you want to ask something.
Hello.
Hello.
Hi.
Hi. The webinar is very interesting and very useful.
Thank you.
Thank you.
Thanks for the webinar.
Great.
Thank you.
Thank you very much, Krishna. So Mostafa, I'll let you just for you to read the questions and answer them, okay?
Okay. So I have a question from Karisha. For BIM in construction, are emerging technologies like AI and IoT being integrated with BIM to help with decision making and real-time updates you mentioned, or are we still too early? We aren't seeing this yet. So I had one slide, to be honest, that I skipped to allow for the time for questions. related to this part. And there are examples where some I won't say it's complete experience, but there are examples where this has been applied. For example, I saw an example for railway modeling was connected into sensors that detect the wearing of components of the railway to visualize which parts need to be which parts of the rail need to be to have the maintenance and so on. So it's being used, and it's partially, it's not implemented as far as I saw in complete projects, but also there are other examples that I saw and presented in the masters where complete models of railway projects were used for trainings, for example, and were used for getting involvement for the operators of the railway to better understand the design and decide locations for the signaling units. So it's I won't say it's 100% mature at the moment, but it's going there. And one of the obstacles for sure is the sizes of BIM. So you can see it more applied in GIS or using GIS, but in BIM it's still developing. Another question is, what are the authoring tools can be recommended? So I think this is already covered in the session. I'll try to pick some more questions. One moment.
So Mostafa, there are a couple of questions regarding software. You talked about this, but they're asking the basic software and for railway clash detection. And they're asking if in the masters you teach the practical implementation of these tools.
Yeah, so mainly we cover in the master Autodesk InfraWorks and Autodesk Civil 3D. These are the main tools used for the modeling and detailing. However, for clash detection, it's very common to use Navisworks or Revisto with this workflow. However, if you are using other tools rather than Autodesk software, so for sure you will be using other clash detection tools. So it's implementing BIM in railway projects. Yes, for sure it needs capable software, but also it's more related to the processes that can control this size inside the software.
And Adam is asking, is InfraWorks a cloud-based software?
Mainly yes, but also it have an option to save locally. So the best use of Autodesk InfraWorks is using its cloud connection to Autodesk Docs, and also it need to be so. This is when you are saving your project, but also when you are working directly on Autodesk InfraWorks, you need it to be always connected to the internet, because you load satellite imagery using internet, you connect it, for example, with ArcGIS using internet. So it's better to use it or to consider it as a cloud-based solution.
Great.
Another
yeah.
question, yeah, you can
Salam.
go because.
Will you go through rail design or just rail modeling?
No, we focus on the BIM aspect of it. Yes, for sure, we give an introduction, a very good introduction about the design principles behind this, but we consider that the team attending this or the personnel attending these sessions are more focused on BIM and how BIM can facilitate the design. So we give the theory and what are the basics of design of railway, and then we say how BIM can support this.
Great. So we have really positive comments, Mostafa. Karisha says that you're always most insightful.
Thank you.
And then Yasser says that he always follows your updates in LinkedIn. So
Thank you. It's my pleasure.
thank you very much. So I think we have addressed all the questions. So
Perfect.
as I said, you'll be receiving the recording, and then just don't hesitate to just go to the landing page, put your information, and we'll give you any more details that you want. Okay.
Sure.
So I
And
think
feel free to reach out if something, if any questions you want to ask later, feel free to reach out. I'll be more than happy to answer that. I'm always on LinkedIn.
great. Well, thank you again, Mostafa. Thank you very much. Thank you all for joining us, and we hope to see you again in a later masterclass. Bye-bye.